Now, a kite is a rhombus when the diagonals intersecting at the centre need to form a right angle, and they need to be perpendicular. Well, it's the same thing. So the rhombus isn't always a kite, as you can see the case over here, because for this to be a kite, this would have to be at 90 degrees. I don't think that's quite 90 degrees, but it's close. But you can see the similarities there. So what we need to see is we've got two triangles. We've actually got four triangles, but we're just going to look at two. And what I've done here is shown how the area of a kite is half of d1 times d2, and that's the formula for finding the area of a kite. I've done that by adding the area of the two triangles. Now the first area, you can see 1, 2, 3, 4, 5, 6, 6 square units for the first area of the first triangle, and 6 square units for the area of the second triangle, which is triangle BAD flipped over like so. Those two triangles are exactly the same, and we've used the area of the triangle, which is half base times height. So you add the two areas of those two triangles together and you get 12 units squared. Now when you see that, you kind of are less reliant on learning another formula, which is half of diagonal 1 times diagonal 2, or half of d1 times d2. Because you can just quickly see, okay, I need to find the area of this triangle, add it to the area of this triangle. That's just in the exams. If you happen to forget what the formula is for area of kite, you can revert back to that, and you'll be fine, because you'll get the right answer. It doesn't matter how you get there, I guess. It's just as long as you get there in the end and you show your reasoning for it. So to rehash what I've done in previous videos, we've got the formula, we've got the working out, and we've got the answer, which is what is essential in mathematical thinking. And that's it, that's kites. We could get into the algebra of this, but we're not going to. I'm going to very quickly move on now to rhombi, or rhombus, to find the area of a rhombus. So with rhombus, that's what you can see. A rhombus is a parallelogram. So we've already talked about parallelograms in previous videos. Now when the rhombus is a kite, you can apply the formula as we've done here. When the rhombus is a kite, that is when this is a perpendicular, the intersecting middle diagonal lines are perpendicular, you can apply this formula for finding so if you're given the length of diagonal 1 and diagonal 2, you use this formula, this formula here, to find the area of the rhombus. When you're given the base and the height, as is the case here, so we've got a different size of rhombus. This is not this rhombus anymore, this is this one. So the base, you've got to see that if you move this over, or if you move this triangle over to this makes, again, a rectangle. So it's the same formula as the area of a parallelogram. So area of the parallelogram, or the rhombus, that's a bad rhombus, but you get the idea, equals base times height, which in this case equals 2 times 2, and the area of the rhombus equals 4 square units. I very deliberately haven't given the units a measurement label, for example centimeters or inches or whatever, because everyone else seems to do that. I'd rather stick to the universal language of mathematics. Okay, so that's the area of rhombi and kites.